Assalamu alaikum students. In this video, I will teach you a method of sketching the quadratic functions. But before this, I am going to ask you a question. Have you ever seen any example of quadratic functions in nature? A rainbow. It is a perfect example of the quadratic functions in nature. The shape of a quadratic function is a parabola. If the coefficient of x square is positive, then the parabola open upwards and the graph has the minimum point. And if the coefficient of x square is negative, then the parabola open downwards and the graph has the maximum point. We need three things to sketch the quadratic functions. Number 1, x-intercepts. Number 2, y-intercepts. And number 3, the turning points. Y-intercept. Y-intercept is a point where the graph cuts the y-axis. To find this point, we need to put x is equal to 0. After doing this, we have y is equal to some constant c, the y-intercept. X-intercepts. These are the points where the graph cuts the x-axis. To find this point, we need to put f of x is equal to 0. Hence, we have a quadratic equation. By solving this quadratic equation, we may have these 2 points. Turning point. To find the turning point of the graph, we have too many methods. One of them is use of complete square form. When we express the given function in complete square form, then the numbers p and q in ordered pair is the required turning point of the quadratic function. Here we have some more examples of turning points and their nature. When we express the given function in complete square form, then we have the numbers 3 minus 1 in ordered pair is the required turning point. In this example, the coefficient of x square is positive. So the shape of graph is a parabola open upward. The graph has a minimum point and the minimum value is minus 1. For the graph y is equal to 8x minus 4x square minus 9 in complete square form is minus 4 into x minus 1 whole square minus 5. In this case, the number 1 and minus 5 in ordered pair is the turning point of the graph. Here the coefficient of x square is minus 4. So the shape of graph is a parabola open downward. The graph has the maximum point and the maximum value of this graph is minus 5. Now we sketch these two functions one by one and step by step. For this, consider y is equal to x square minus 6x plus 8. To find its y-intercept, we need to put x is equal to 0. So we have y is equal to 8. For x-intercept, put y is equal to 0 in given function. Here we have a quadratic equation. By solving this quadratic equation, we have two values of x, 2 and 4, means there are 2 x-intercepts. Mark these 2 points on the graph. For the turning point, we need to express the function in complete square form. Here the point 3 and minus 1 is the turning point of the graph. Now join all these 4 points smoothly. Hence the required graph. Now we have to sketch y is equal to 8x minus 4x square minus 9. To find its x-intercept, put y is equal to 0. We see that the equation has no real values of x. It means there is no x-intercept. For y-intercept, put x is equal to 0. Here we have y is equal to minus 9. Mark this point on y-axis. For the turning point of the graph, express the function in complete square form. Here we have 1 minus 5 as its turning point. It's the maximum point because the coefficient of x square is minus 4. Mark this point on the graph. Now join these 2 points smoothly. Hence the required graph. Someone may ask, what is the real life example of this type of graphs? For those, I have this picture. Okay, see you in next video. Take care.